This is CS1101, lecture 3.1. We're going to continue our discussion of methods along with introducing parameters and return values. So a quick reminder on identifier naming. We always capitalize the beginning letter of class names and then use camel case for any other multi-word names. So in the case of string, the S would be capitalized and that's all. In the case of hello world, the H in hello is capitalized and then the W in world is capitalized. So we have initial capitalization and then we have camel case from that point. Method names and variable names, regardless of what type they are, what type they return, we always start with a lowercase letter and then continue in camel case. Remember to choose names which are meaningful and descriptive so that it increases the readability of the program. Reminder on when to use a static method. Groups of statements should be placed into static methods when the statements are structurally related and or the statements are repeated. In the case of the shape drawing program, we had situations where we may want to draw multiple eggs, so this made it advantageous to put all the statements which are used to draw the egg into a method together, so that anytime we want to draw an egg, all we have to do is call the draw egg method, similar with the cup, the hat, and the stop sign. And then we also realized that there were certain common shapes that we called shape primitives that we would be drawing multiple times, so it was advantageous to put those into methods and then simply call those methods from our draw egg, draw cup, draw hat, and draw stop sign methods. So in this situation, those had repeated functionalities, and to reduce redundancy, we would group the statements into methods and then call the method to be able to reuse that code multiple times in our program whenever we want it. On the other hand, we don't use static methods in situations where you're going to place an individual print line statement into a static method. That doesn't make much sense. You also would not use static methods to group unrelated portions of code. So the example I used previously was if you had a 30-line main method and you simply wanted to clean up the main method and reduce the amount of code present, it would be incorrect to take the first 15 lines of code and put it into a method and then replace those 15 lines with a call to that method in the main program, simply because you wanted to clean up the code and make it appear more structured. It's going to be obvious when we go to look at the code that there is no actual underlying structure there. There is no actual relationship, and the use of a method does not increase the readability, and it does not increase or decrease the redundancy in the program. Therefore, a method was the improper use of methods. So make sure that you don't arbitrarily introduce methods, but you introduce methods when they're appropriate, when the statements used in the method are related and the statements used in the method you believe will be repeated, and therefore it's useful to house them into a method so that you can easily reuse that code. And then as far as the ordering of methods within the class, just be consistent and put the main method at either the top or the bottom. The top is most common, but again, just be consistent and have a reasoning behind what you choose to do. So let's go back to our customer receipt program that we used from the last lecture. We left it in a good place. We're using class constants to store our tax rate and tip rate. Notice that class constants, again, are all caps separated by underscore for multi-word class constants. And the declaration public static final, followed by the type, the name, and then the assignment of the value. We also have decent commenting. We have comments on our class constants, and we have comments on the block of code containing our variables. So it's easily read and understood what this program does. But now let's introduce methods and see if we can't make this program better. Okay, so let's begin to upgrade our customer receipt program. First, let's make concrete exactly what we expect the program to do. First, it will always be understood that each customer will have eaten an appetizer, meal, and dessert, and the program then is expected to calculate the subtotal, tax, tip, and total owed for the appetizer, meal, and dessert. The program follows straight from this. We're going to have to calculate and display the subtotal, calculate and display the tax, calculate and display the tip, and finally calculate and display the total owed. So if you think about it, when you understand what the program is intended to do, that is understanding the scope of the program. Then you look at how can this program be decomposed. And a good way to think about decomposition is how might you split up the work in a team environment. So if we had 4 people involved with doing this program, with writing this program, then we might tell the first person to write a program which calculates the subtotal and displays it, the second to calculate and display the tax, the third to calculate and display the tip, and finally someone to calculate and display the total. Now, the steps are going to have to be interlocked because the person who calculates the subtotal is going to have to give information to the tax and the tip, and the person who calculates the total owed is going to have to get information from all 3 previous individuals. So it's not to say that they can be completely independent, but by splitting up the tasks in this manner, we can see how you might split this up in a team environment. Think of using methods in a similar way to assigning pieces of a project to team members. So each one of these functions can be assigned to a method. Whenever you begin to conceptualize a new method or a new any new section of code, it's usually best to write it in pseudocode before you write it in actual Java code. The reason is because pseudocode lacks any of the structure and rigor of actual Java, and it helps you think about it logically and structurally without getting bogged down into the details of a specific programming language, having to worry about variables and such. So we will want to have a method called calculate subtotal based on our decomposition that we used from the previous slide. And this calculate subtotal is going to add up the 3 values, and it's going to display the subtotal. And that will accomplish exactly what the calculate subtotal is supposed to do. So it's not very complicated, but we have fully defined exactly what we expect from our method in pseudocode. Now let's convert this pseudocode into Java code. So here we have a method which attempts to do what we said in pseudocode. We are adding up the 3 values, and in this case we're adding up 18, 40, and 10, so it can't be changed. This only works for an appetizer that's $18, a meal that's $40, and a dessert that's $10. And then we pass the result of this expression to a print line statement, and that shows to the screen. So we are adding up the appetizer, meal, and dessert and showing it to the screen. So I guess technically this satisfies our pseudocode, but we can't use any other values, right? We can't buy an appetizer that's, say, $6 or $30. So this is pretty limiting as for when this program would be applicable. It'd be better if we had a way to use parameters to pass in what we wished to what we wish the price of each of the meal, appetizer, and dessert to be. So in Java, a parameter or argument, you can use those interchangeably, is a value which is passed to the method by the caller. So instead of hard coding 18, 40, and 10 into the method, we'd like to be able to add up any three values which the caller would pass as parameter. To be able to use parameters in a method, we have to declare the method in such a way that we tell it we intend to pass it parameters. So that's the first key step. And then the second is, once we have declared a method that we've said we're going to use parameters with, we have to follow that up by calling the method and supplying the parameters that we said we were going to supply it with. So let's look at the syntax for declaring a method which will expect parameters. So in general, we start methods with public static when declaring, and in this case the return type is void because it will not return anything, and the method's name will go in the next location. Remember, methods are named with a beginning lowercase letter and then camel case from that point forward for any multi-word names. Then in parentheses, this is where you show that you intend to pass parameters. You have to give the type of the parameter, so what data type the parameter will be, and the name that the parameter will have. So here's an example. Public static void, so again, return type is void, so we're not going to return anything. And then we have the name, and starting with lowercase followed by camel case, so display magic phrase. And then in parentheses, we're telling the compiler, hey, this method is going to have a parameter, and that parameter is called phrase, and it is a data type string. So we're going to be passing a string into this method. And then inside this method, we can make use of this passed parameter simply as if it were a variable. So anywhere we see the name phrase show up inside this method, then we understand that we are accessing the value that has been passed to this method. So in this first statement, we see we have a print line statement, and then we have a string. So the magic phrase is colon, and then we are ending the string, and then we have an addition operator, the plus, and then we have phrase. So what's going to happen is this string is going to be concatenated with whatever string has been passed to the method by the caller. So then when display magic phrase is called, the calling statement must pass along the value to be printed. So what I'm saying here is, in our main, when someone types in display magic method, they have to also, in parentheses, write whatever they want to pass. And they can supply it with a variable, or they can supply it with a string literal. But this is where, in those parentheses, they must give what they intend to pass as the parameter phrase. A good way to think of this is sort of a handoff in a relay race. So your calling method is going to specify the value and hand it into the method. So the general syntax for this, if you remember, we said that the general syntax for calling a method with no parameters was simply the name of the method followed by open and close parentheses and then a semicolon. Well, we're going to modify that. Now, whenever we have parameters, we're going to have in order to call the method which has parameters, we have the name followed by open parentheses and then whatever parameters we are going to be passing. So that can be an expression. We can pass it as a combination of of operators, we can pass it as a literal or we can pass it as a variable. Remember that each one of those would be considered an expression. The idea of an expression is quite broad. If you need to recap that, I would go back and look at it. So in general, we can pass any expression to a method as the parameter. So the calling statement does the initialization of the value for the method. So here's an example of this. We've got this magic phrase method that we created from the last slide. Now let's pass some strings to the magic method, to the magic phrase method. So here's our main, and here is the first statement in the main. So this is where we will begin executing. So the first statement is a call to magic phrase, and we are passing the value abracadabra. Now notice how it's supplied. It is a string literal. A string literal is an expression, so this matches what we said in the general syntax. So we're passing the string literal abracadabra into magic phrase. And inside the method magic phrase, it will print out the string the magic phrase is concatenated with the string which has been passed. So the magic phrase is, and then we concatenate abracadabra and display that to the screen. Remember how program flow works when you're dealing with methods. So we jumped into the magic phrase method, then we executed all the statements in the magic phrase method, then we're going to jump back to the calling location in the main. Then we're going to execute the next statement, and so our program pointer is going to again jump into magic phrase, but this time magic phrase has been passed the string Hakuna Matata as the parameter phrase. So the magic phrase method will display the magic phrase is concatenated with Hakuna Matata, and then the program pointer will jump back to the main. And this is very useful because now this magic phrase method doesn't simply display one specific phrase. It displays a common preamble and then whatever we pass it. So anyone can have any specific magic phrase that they wish to have, and they'll be able to display it with a consistent preamble. So this reduces repetition because we don't have to write the magic phrase is each time, and instead we can simply make use of this call and pass whatever the new magic phrase happens to be as a parameter. And methods are even more powerful because we don't have to only pass a single parameter. That would be somewhat limiting if we could only pass a single parameter. Rather, we're able to pass an arbitrarily many number of parameters. So the syntax for passing multiple parameters is very similar to that of passing a single parameter. We have the public static, then in this case again we have a void method, so it's not going to be returning anything. We have the name of the method, and then in parentheses we list each parameter. And just as we did with a single parameter, we have to give the data type and the name for each of the parameters, and then the data type and name for each parameter will be separated by a comma. So as an example here, we can have a method which will calculate the area of a rectangle, and we'll declare it using public static void. So it doesn't return it, it just displays it. If it was returning it, it would have to have a return type, but instead this is void, so we're not returning the value. And then we give the name calculate area, calc area, and we have defined that we are going to have two parameters. So the first parameter is length of type integer, and the second parameter is width of type integer. So now anywhere in this method where we see length, we understand that we are making use of whatever value was passed by the caller. Similarly, anywhere in this method we see the word width, then we understand that we are making use of the width which was passed by the caller. So then our method is very simple. We only have a single statement in it. It's a print line statement, which is the area is, that's a string, concatenated with length times width. So just really quickly, let's remember how precedence works with operators. We have an addition operator and a multiplication operator. Multiplication is higher precedence than addition, so therefore we're going to perform the multiplication first. So we're going to do length times width and get the result of that expression, and then we will have a string plus the integer result of that multiplication. So a string plus an integer is going to result in a string, and that will be a concatenation. So we will have the area is, and then whatever the resultant area is displayed to the console. An important note here, remember to always supply the parameters in the specific order which was defined in the declaration of the method. So it would not work. Well, in this case it would, because the length and width can be swapped and you'll wind up with the same result. However, consider if this were calculating the area of a triangle, then if we were to swap the base and the height of the triangle, we would not wind up with the same result. So the values will be passed in the order defined in the declaration. So when we call this calc area from the main, if I define the length in the call to be 5 and the width in the call to be 2, then the length here will take on the value 5 and the width will take on the value 2. So we are defining the value of length and defining the value of width in the call here and here. If I were to swap those up and I were to instead accidentally pass the 2 first, so I would be thinking that the order of parameters was width then length, then the effect would be that inside the method, the length would take on the value 2 and the width would take on the value 5. The point is, when Java executes your program, it knows which value to place into which parameter based on the order which you supply them. So I'm calling calc area, and I supply the 5 first, and the first parameter is the length. So 5 goes into length. I supply the 2 second, and the second parameter is width. Therefore, 2 goes into the width. So this is how Java knows which value goes into which parameter, by the order. So order is very important. So now let's look at the syntax a little closer for how to call a method that has multiple parameters. So we said previously, for calling a method with a single parameter, we would call it the method by name, and then in parentheses we would give an expression for the parameter that we wish to pass. Well, we're going to extend that just like we did the declaration, and we're going to separate each parameter we intend to pass by a comma. So we have name followed by parentheses, and then we have an expression for each of the parameters which we are passing to the method. So just as before, the statement which calls the method actually is initializing each value for each parameter. So let's look at our calc area example below, and we have a main method. So when we begin to execute, we find the first statement in the main method, and that's the first statement that will be executed. So calc area, so it's a call to our calc area method, and then we have an expression which will pass a value to our first parameter followed by a comma, and then an expression which will pass a value to our second parameter. So in this case, the expression is an integer literal for both parameters. So the value 10 will go into the length, and the value 8 will go into the width, and we know that based on the order, right? In our declaration we said it would be length then width. So length first then width, and inside the method they are multiplied together and displayed. So it displays the string the area is concatenated with 10 times 8, 80. So at this point, let's discuss exactly how parameters get their values from the caller. So if you remember, we said that each parameter which expects a value must be supplied with an expression, right? So when we call our method, we must supply an expression which will evaluate to a value for each of the parameters which were defined in the declaration of the method. This idea where each parameter is supplied an expression is important because each expression will evaluate to a value, and this value is what will actually be given to the parameter. So the parameter will take on the value of whatever expression we supply when we call the method. So let's look at this in a concrete example. So below we have a main where we declare a variable, an integer variable length and we supply it with the value 10. Then we declare an integer variable width and we assign the variable we assign the value 8. Then the next statement is a call to our calc area method, which we have duplicated below. And a couple of notes here. Notice in the declaration of the calc area method, we have two parameters, an integer L and an integer W. And those are the names of the variables, L and W. So we changed it slightly from the previous version in the previous slide. So inside the method, we have a print line statement, which displays the string the area is and concatenates that string with the value which results from multiplying L times W. So, in the case where L was 2 and W was 5, it would be the area is 10. Okay, so going back up to our main method where we're calling calc area, we are going to supply an expression for each of the parameters L and W. So the first expression for L is just the variable length. Remember, an expression can be simply a variable. It can be a literal. It can be a system of operators. So we could have, rather than just placing length here, we could have said calc area 2 times length. This would have also been an expression. But instead, we just chose to use length. Now, understand that this is an expression, as I've repeated multiple times. So the variable in this case is going to evaluate to its value. The value of length is 10. So 10 will be passed to L. There is no other association between length and L. They are not linked in any way. The only relationship they have is that the value which was stored in length is the value of this expression, and the value of this expression is then copied into L. So if down here past this call statement we change the value of length, that has no effect on the value which was passed to the method calc area. The same is true of width. So this is an expression, and the expression is just the variable width, and this expression evaluates to the value 8, and the value 8 is then copied into the parameter W, and then they have no more association. So all that happens, the only association that the variable used in the call of a parameter, the only association it has with the parameter itself is that the value of the variable becomes the value of the expression, and the value of the expression is stored into the variable. There is no continuing association past this point. So there are several common errors that are going to crop up most likely when you start using methods with parameters. The first of these errors that you will probably encounter is trying to call a method which you have declared and told it, yeah, I'm going to pass parameters, and then when you call it, you pass either no parameters or the wrong number of parameters. So in the case of calc area, we told in the declaration we are going to pass L and W. So we're going to pass two parameters. If we call calc area and supply no parameters, as is the case here, this will throw a compiler error and it'll say parameter value required. If we call calc area and we supply three parameters, it'll say that is also an error. So calling a method with the incorrect number of parameters will result in a compiler error. The other issue that you are liable to run into is calling a method and supplying the wrong data type value. So when we supply an expression for each of the parameters which have been defined in the declaration for the method, if that expression evaluates to a data type that is incompatible with the declared data type for the parameter, it's the exact same as trying to assign a variable with the incorrect data type. So if you remember, in calc area, L and W were declared as integers. And we know from previous lectures that you cannot assign a double value to an integer without using a typecast. So very much the same. This is an expression which is a double literal, and this double literal will take on the double value 5.7, and we're attempting to store the value 5.7 into an integer. That will not work, and it will give a compiler error and say it must be the correct type. So these both should be expressions which evaluate to integers in the case of calc area. So the type has to match the expected parameter type. Now remember, like we said, some types can be promoted. So if, for instance, in our calc area method we had declared that each of these parameters would have been integers, or would have been doubles, then this would work. Also, we could supply this with integers, and the integer would be promoted to a double. So the rules that we defined for variable types also apply here for parameter types. So going back to this receipt method, which we're trying to code, we require three parameters to be able to calculate the subtotal for an arbitrary meal, which consists of an appetizer, meal, and dessert. So we need the value or the cost of the appetizer, the cost of the meal, and the cost of the dessert. Now previously we only allowed these to be integer values, but if we're being realistic, they should be allowed to have decimal places, right? So we're going to use double values instead for appetizer, meal, and dessert. We'll keep the display fairly simple, but we will use a $sign to designate that this is a dollar value amount. So now let's look at our method which we have added parameters to. So we have public static void. We're not returning anything, so it's a void method. And our method name is calc subtotal. Then we have our parentheses, which begins our parameter declaration area. And if you remember previously when we defined this method, we just had open close parentheses because we weren't passing any parameters. Now we're passing parameters. So our first parameter is apps, and it's of type double. The second parameter, separated by a comma, is entree of type double. And the third parameter is dessert of type double. So now let's write the code necessary to sum these and display them with some sort of statement about what we're displaying. So first of all, we'll display subtotal and a $sign, and then we will do a carriage return. So that can be accomplished using a printline statement. In the following statement, we have a printline statement, and we are going to print the summation of all three apps, entree, and dessert. So notice that printline, we said, is a method. So we are passing a parameter to the printline method, and we are passing it an expression which evaluates to the summation of the apps, entree, and dessert. And so the value which this expression evaluates to is, in the case of 18, 40, and 10, is 68, and therefore 68 is the value that is given to the print line method. So here is the current state of our calc subtotal method. So is there any way you can think of that we could make this better, that we can improve the current state of our calc subtotal method so that it is more functional? And this kind of goes back to our decomposition. Originally in the decomposition we said we were going to have methods to calculate the subtotal, tax, tip, and then finally the total. But we didn't necessarily require, I alluded to it, but we didn't require that the methods would share information or return any values. So right now each method is having to calculate the subtotal in this case. But then think about it, if we don't supply the subtotal to the method which will calculate the tax, it will also have to calculate the subtotal to be able to calculate the tax. So we're having to redundantly calculate the subtotal. So maybe a better decomposition would be that the calc subtotal method will return the subtotal so that each subsequent method does not have to continue to calculate that same value redundantly. A further consideration is maybe this is going to be used by a company in the future, and that company would like to format their own printout, in which case it would be better to calculate the subtotal and return that value and not display it in the same method which we calculated. By separating the calculate and display, we're able to more finely control each and allow some other method to decide how it gets displayed at a later date. So in order to do something of this type where we share information or allow some other method to handle the display, we'll need to introduce returns so that we can return a value to the caller. But before we move on to returns, let's go over parameters just a bit more to ensure that we understand exactly how they work. So here's an exercise to test and see if you have fully understood how parameters work. So take a moment, pause the video, work through this example exercise, and see if you can figure out what the output will be before I show you. Okay, we have a class which is called parameter mystery. Notice P is capitalized because this is a class name. Yeah, there's a slight error. So there should be a curly brace here. So we have the class parameter mystery, and we have two methods inside this class. We have the main method, and we have a method called mystery, which returns no values. And seems that mystery will do some math calculations and then prints out some expression. Then our main is declaring several variables, 3 variables, and calling the mystery method, and then printing out the variables, and then calling the mystery method again, and then printing out the variables. Execution always starts with the first line of the main, the first statement in the main. So the very first statement declares a variable x, y, and z of type integer. And variable x takes on the value 5, y takes on the value 9, z takes on the value 2. Then we call mystery, and mystery is declared with 3 parameters, x, z, and y. So we have to supply expressions for each of these parameters. So we have an expression here for x, we have an expression here for z, and we have an expression here for y. So the first expression is going to look at the variable z and evaluate to the value 2. So x will take on the value 2. So let's write this down as we execute it. So this is the value 2. So this takes on the value 2. The second expression here, which will provide the value for z, will evaluate to 9. And then lastly, our expression for y will evaluate to 5. Notice the fact that the variable names don't line up or don't match is meaningless. All that happens is each of these is considered an expression. The expression evaluates to a value, and that value is copied into the parameter. So y takes on the value 5. Now, inside our method, because when we arrive at this statement in the main, we are going to evaluate these expressions, copy those values into our parameters, and then our program pointer is going to jump into the first line of the method that is being called. So at this point, we have x++. So this is a post-increment operator, but it's the only thing in the statement, so it has the effect of incrementing x. So we wind up with x being 3. So rather than write it over here, we'll keep it here. So x is now 3. Then we assign y the value z minus x. So that would be 5 minus 3, which would be, z is 9. So it would be 9 minus 3, which is 6. So y is now the value 6. And then the print line statement will print out 3 space 6 space 9. So we have our first line of output. So we have reached the end of the mystery method. So the program pointer will jump back to the calling statement and will then increment to the next statement. So the next statement is a print line statement, and it will print x, y, and z. So this will print 5, 9, and 2. So let me reveal the output so far we have. So our output so far, 369 due to the mystery method, and then we just had 592 displayed because of this print line statement. So now let's move forward. After our print line statement, the next statement is a further call to our mystery method. So we will forget the values which had been previously used in the mystery method, and we need an expression for x, z, and y. So our expression for x is first, and it evaluates to the value which is stored in y. The value which is stored in y is 9. So then we need an expression for the parameter z. The expression for the parameter z evaluates to 5 because 5 was stored in x. And then we needed an expression for the parameter y. And the expression for the parameter y, shown here, evaluates to 2 because 2 was stored in the variable z. So our parameters take on these values. So just as we did last time, we increment x, so x becomes 10. then we will assign y the value which results from the expression z minus x. Z minus x is -5, so y is assigned the value -5, and then we will print 10 space -5 space 5. So let's check our output and make sure that we got that right. Yes, 10, -5, 5. So now, once again, we're at the end of our mystery method, so our program pointer will jump back to the calling statement and then increment to the next statement. And the next statement is a print line statement, once again printing out x, y, and z. And so we will print out 5, 9, 2. See if that's correct. 5, 9, 2. So hopefully you were able to trace through the execution of this simple program and understand how the parameters in our mystery method are passed values by the calling statement. Okay, now let's move to returning values from methods. In order to return a value from a method, the body of the method must contain a return statement. And the syntax used for a return statement is the keyword return followed by a space and then expression. So this expression, again, can be any expression. It'll evaluate to some value, and that value is what will be returned. Now, one thing that we will discuss further in a moment is each method that returns a value must be declared with a type so that the compiler knows what data type the method will return. Therefore, the expression that you define in the return statement must produce a value. It must evaluate to a value of the type which was declared in the method declaration. Now, inside the body of a method, you may have multiple return statements for various reasons, but specifically if you were choosing between multiple possible return values, then one way you may go about that is actually having a set of if statements and then multiple return statements based on which if is true. But once a return statement occurs, so even if there is a significant portion of code after the return statement, as soon as a return statement is executed, then a value is returned from the method and control immediately goes back to the caller. So as soon as a return statement occurs, the value which is returned is given to the calling method, and the program pointer jumps back to the calling statement. When it's possible or when it's reasonable, it's often better to use a single return statement simply because it usually makes for cleaner and more readable code. So now let's look at a simple method which will return an integer value. So we declare our method public static. That's the usual recitation we've been using. Now, I've been pointing out previously that methods had the keyword void in this location. So most of the methods up to this point we've looked at have said public static void. So void indicates that there is nothing being returned. However, now we do want to return something. So instead of saying public static void, we're saying public static, and then this is now the type of what will be returned. So we're going to return an integer. And our method name is calcArea, and it requires two parameters, L and W, just as it did previously. Now, however, it does not simply display the area. Now it will return the area. So we have a return statement inside the method, and we have an expression given to the return statement. The expression is L times W. This will evaluate to a value, and this value will be an integer value because it's an integer times an integer, which will result in an integer. And then this integer will be returned to the caller. This is known as the method heading, while everything in curly braces after that is known as the method body. A similar version of the same method could have been made, which stores the area in a variable, and then the variable is included in the expression. So just to be clear, we could have had the method heading public static int, because we're going to return an integer value, calc area, int L, int W. So two parameters, L and W. And then we could have declared a variable inside this method, area, of type integer, and we could have assigned area the expression L times W. That expression obviously will evaluate to the area, and we have stored it in the variable called area. Then we have a return statement, and we must supply the return statement with an expression, and so our expression just consists of the variable area. Area will then evaluate to whatever value is stored in area, and so we are returning the value which is stored in area. This would be another way of achieving the same functionality that we described above. So here we'll describe a few methods that do simple math calculations, but this is helpful because you can use this to solidify your understanding of how returns work and how parameter passing works. So the first method here is going to calculate the slope between 2 points. So let's look at the method heading. We have public static. Those are our keywords for beginning the declaration of a method. Then we have the type that is going to be returned by this method. And then we have the name of the method, slope. We have 4 parameters that we have to pass to the method: x1, y1, x2, y2. So each of these will be an integer, but then we're going to want to return a double. So keep that in mind. So in the body of our method now, we declare a double called dy, and dy will be the change in y, and we assign it the expression y2 minus y1. Then we declare a double dx, which will be the change in x, and we will assign it the expression x2 minus x1. So then we are declaring a double called result, and result will be assigned the expression dy divided by dx. So notice here, dy was assigned the result of the expression y2 minus y1. y2 and y1 are both integers, so this expression will evaluate to an integer. But then we are assigning an integer value to a double variable. So this integer value will be promoted into a double. The same thing will happen with x2 minus x1. It will evaluate to an integer and then be promoted into a double when it is stored in dx. Then we have dy divided by dx. Both of these are doubles and will evaluate to a double, and that will be stored in result. Then we have a return expression. We have a return statement, and the expression in the return statement simply contains the variable result. Result will evaluate to whatever value is stored in result, and our method will return the value stored in result to the caller. Okay, now let's look at a method that will round to 2 decimal places. We already looked at this previously. We said the way to do this would be to multiply by 100, then use the math round function, and then divide by 100. So it should be similar to that. We have in our heading public static, and then our type is double. All right, so that's our return type. We are going to return a value of type double. We have the name round2, and we have 1 parameter, which is the number to be rounded. So we are going to declare an integer variable called scale up, and we will assign it the expression integer cast n times 100 plus 0.5. So n times 100, n is a double, so n times 100 will move the decimal place 2 places to the right, and we will add 0.5. Then we will cast this to an integer, which will chop off any of the decimal portion of the number. So let's make this concrete really quickly, how this algorithm works. Let's use the number 0.333 as an example for n. So n equals 0.333. So n times 100 will be 33.3. And then we add 0.5. So this will be 33.8. Then we're going to cast that to an integer. So we will drop the decimal, and we wind up with 33 being stored in scale up. Notice, if we had been at 33.5, at which point we would want to have rounded up, then when we added 0.5, it would have summed to 34. So when we cast it to an integer, we would have achieved 34. This adding 0.5 and then casting to an integer is a common method used to effectively round something. So now we have 33 as the value for scale up, and it's a type integer. We are dividing it in the next statement by 100 to move the decimal back to the left 2 places, and the result of dividing an integer by a double is a double, and we store it into the double result. So we have 0.33 stored in result. Then we have our return statement with the expression result, which is just the variable result, and result evaluates to the value which is stored in it, in this case 0.33, so this will return 0.33 to the caller. Sometimes you may be able to shorten methods by actually doing any of the operations or several of the operations in the actual return statement. So we said that a return statement requires an expression for the value which is to be returned. Well, this expression can be as complicated as you desire it to be. So in this first example, rather than calculating the slope and then returning the results, we could simply calculate the slope in the expression defined to return a value. So in this first one, we have y2 minus y1 in parentheses, as well as x2 minus x1 in parentheses. So whatever's in parentheses gets evaluated first. Y2 minus y1 yields an integer. X2 minus x1 yields an integer. The next highest precedence operation in this expression is the typecast. So we will apply a typecast to the result of y2 minus y1. So we will cast that to a double, and then we will do a double divided by integer, which will yield a double, and we are that is the value which this expression evaluates to, and then we return that value back to the caller. Similarly, in the bottom, we have the parentheses is evaluated first. So just as we did previously, we multiply the number by 100 and then add 0.5. We cast that to an integer to chop off the decimal place. It's truncated, not rounded, but because of the 0.5, this effectively rounds it. And then we are dividing by 100.0. So this is a double literal. So we have an integer divided by a double, in which case the result is a double. So this expression evaluates to the rounded to 2 decimal places version of n, and then we return that expression value to the caller. To summarize, when declaring a method that returns a value, you use the keywords public static followed by the data type. The data type defines the type of value, the data type of the value which will be returned. Then you have the method name, and any parameters which you are going to pass to this method, and then you must have a return statement, and the return statement consists of the keyword return followed by an expression, which will evaluate to a value, and the expression must evaluate to a value of the type double in this case, but whatever type you have defined in the method heading. So the method heading is the public static data type and name, as well as any parameters defined, and then the method body is everything in curly braces. Then when the method is called, you supply it with parameters. So in this case, we are using the method calc subtotal, and we are supplying it with the values 18, 40, and 10, just as we did previously. Then calc subtotal is going to return the subtotal. When it is returned, we must store it somewhere. So this is very similar, because this will sum these things to 68. This is functionally the same as having written here 18 plus 40 plus 10. So if we did that math, we would have to store the result somewhere into a variable. So just as we would have to store the result of doing addition in Java, we have to store the results of calling a method which returns a value. And so we are going to store this returned value into the variable subtotal. It's a common mistake when you begin to program and you're using methods to expect that the method will actually send the value back to a variable, but this doesn't happen magically. You must have a variable assigned the value which is returned. So in this method shown here, we have main method, and when it begins to execute, we have in the first statement a call to the calc subtotal method, and it sums 18, 40, and 10. Well, the returned value is not stored in a variable, so it just goes away. Nothing is done with it. So then when in the next statement we are attempting to print the line, the subtotal is subtotal, this subtotal here is an undefined variable. We have not defined it in this method, so therefore it does not exist. If we were to do this correctly, we would have to define the variable subtotal, we'd have to declare the variable subtotal, and then we would have to assign it the value which results from calc subtotal. So what is happening is the method is sending a value back, but we have to store that value somewhere if we intend to make use of it. So here is a main and a method which returns a double. Execution begins with the first statement in the main. So we have a variable declared called s of type double, and it is being assigned a value. Now, we talked about this in a previous lecture, but anytime you have a variable that is assigned a value, there's some expression to the right-hand side of the assignment operator. And we always evaluate the expression to the right of the assignment operator before we attempt to store anything into the variable. So we evaluate this expression, and to evaluate this expression, we have to call the method slope. So the program pointer jumps into the method slope, and x1 has taken on the value 0, y1 0, x2 6, and y2 3, and the method then calculates the slope. It gets to the return statement and evaluates the expression result, which will then return the value that is evaluated from the expression back to the expression which called slope. So to recap that, we declared a variable and we assigned that variable some expression, and that expression in this particular case was a call to slope. Slope executes and returns a value, so our expression evaluates to the value returned by slope. Then we assign that value to the variable s. Now, when we make use of the variable s in this next print line statement, s contains the value which was returned by slope. So in this way, we have captured the value and we are able to make use of it in the rest of our program. So let's return to our receipt example program and look at how we could make use of return values. So let's tweak the original decomposition. So rather than just calculating and displaying the subtotal using the calc subtotal method, let's calculate the subtotal and then return the subtotal back to the main. To do this, we will need 3 parameters: appetizer, entree, and dessert cost. In the calc tax method, we will need a parameter to pass the value of the subtotal, and we will calculate the tax and return the tax to the main. We will continue to make use of class constants to store the tax rate. Then in the calc tip, we will calculate and return the tip to the main. We're going to need a parameter for the subtotal because it's going to need the subtotal to multiply by the tip rate, and we will return a double representing the tip. Now again, we'll have to have a constant declared in our main to hold the tip rate. Further, we will need a method to calculate the total or the amount due, right? So we will need a parameter for the subtotal, tax, and tip, and it'll return a double, which represents the total due for the bill. Then we will need a print receipt method. So this is the method which will display all of the information so far. So we will need parameters to represent the subtotal, tax, tip, and amount due, and it will return nothing. So therefore, the type of this method will be void because no return statements will be used, no values will be returned from this print receipt method. And then finally, the last method in this class will be our main. And the main will prompt the user for the values of each of the components of the meal, and then the main will call the various methods to achieve the functionality we desire. We've discussed previously class constants are values visible to the entire class, so a class constant declared will be accessible to each of the methods. So the syntax used to declare a class constant is public static final, and then the data type followed by the name, and then we assign it whatever value we wish to have stored in that class constant. Remember, it is a constant, so this value cannot be changed. It's only appropriate to have class constants for values that, such as tax rate or tip rate, that there is no reason that they would be changed in the program. If they were changed, they would be changed, and it would be a permanent change for the entire class. The convention or the style that is to be used for class constants is all uppercase, and in the case of multi-word class constants, you're to separate each word using an underscore. So an example of this would be public static final, and then our type is integer. Then we have the name, lucky number, and it is assigned the value 7. So now let's put it all together. So first, in our program, the class is called customer receipt, and the file must then be named customerreceipt.java. So remember, class name must match file name. So we have 2 class constants. The first is a double called tax rate, and the second is a double called tip rate. Then in our main, we have a scanner called keyboard, which we will use to get input from the user. This is the reason that we imported java util.star. Then we are going to prompt users for the cost by printing out enter appetizer cost, and then we are going to use our keyboard object to get the next double. So there's a method called .nextDouble, and this will get the value which is typed by the user and return the value as a double. So this is a method. So this is an object. Keyboard is an object, And next double is a method, which is a part of the keyboard object, and it returns the value which is typed by the user as a double. So it returns a value just as we return values from methods. This returns a value, and we capture that value in app cost. Very similarly, we're going to prompt them for the entree cost. We're going to get the next double. We're going to store it in entree cost. Similarly, dessert cost, get the next double, store it in dessert cost. So we will now use the methods that we have devised to do the calculation work. So first of all, we have a variable declared that is a double called subtotal, and we are assigning it the results of the calc subtotal method. So remember, anytime you have an assignment, you're going to evaluate the expression to the right of the assignment operator first. This expression is a method call. So our program pointer jumps into calc subtotal. It'll sum the app cost, entree cost, and dessert cost, and then return the subtotal. So now this expression has evaluated to the value returned by the calc subtotal method, and that value is then assigned to our subtotal variable. The same process we just described is going to happen for this next variable declared called tax. We have a double variable declared called tax. We're assigning it this expression. The expression is the calc tax method. The program pointer is going to jump into calc tax. It's going to use the subtotal. It's going to calculate the tax. It's going to return the value calculated for the tax. And the expression here will evaluate to that returned value. That returned value will then be stored in the variable tax. Same thing with tip. We have a variable declaration and an assignment. We evaluate the expression to the right of the assignment operator. This expression is a method call. The method call will result in a value being returned. That value which is returned will be the value which the expression evaluates to, and that value is stored in tip. And then finally, that same thing plays out for amount due. So we have our subtotal, tax, tip, and amount due each in variables. And then we will print the receipt. So we pass as arguments or pass as parameters the subtotal, tax, tip, and amount due to the print receipt method. And the print receipt method is not going to return anything, so we do not need to capture the value. So it will print the receipt to the console. And this is our entire main method. One thing to notice here, notice the documentation, so notice the comments, but also notice the readability. We didn't need 1,000 comments to portray what was happening in this method because the method was written in a very readable, understandable way. We are going to ask for the appetizer cost, the entree cost, and the dessert cost. And just looking at this code, I can understand that that is occurring because we have print statements and the strings in the print betray that. So it's very easy to understand what is happening. Then we are doing the calculation work. It's very obvious by the method names what we are doing. We are storing the subtotal, which is returned by the calc subtotal. So just by the method name and the variable name, I understand we're calculating the subtotal, calculating the tax, calculating the tip, calculating the amount due. The variable names, the method names, the class constant names, these are providing description and information in such a way that it makes the code readable. This is good code. Use this as an example to judge your code by. Here we have the methods which under the hood are calculating the subtotal, the tax, the tip, and the amount due. We have talked about methods and the execution methods at length at this point. If you need to go over this again, look at each of these closely. Make sure you understand exactly what is happening with any of the parameters that are being passed and how the values are returned. And finally, we have a print receipt, our print receipt method, which is actually going to print to the user console the subtotal, tax, tip, and amount due. So a sample run, the main method is going to prompt the user for the appetizer cost. They enter 18, entree cost 40, dessert cost 10. The various calculations are performed, and then we are going to call the print receipt method, which prints 68, 62.9, 10.2, and the total is $141.10.